In this video, I'm going to be going over questions 15, 16, and 17 from the 2020 AMC 12A. Question number 15 reads, in a complex plane, let A be the set of solutions to z cubed minus 8 equals 0, and B be the set of solutions to z cubed minus 8z squared minus 8z plus 64 equals 0. What is the greatest distance between a point of A and a point of B? So to find the points of A, we're going to solve the first equation by adding A to both sides. So we're going to have z cubed equals A. And to find all the solutions for z, we're going to have z equals a to the 1/3, which is 2, times cosine of 2 pi k over 3 plus I sine 2 pi k over 3. And k here is going to take on the values 0, 1, and 2. And that's going to give us our 3 different solutions for z. If we plug in 0 for k, we're going to have cosine of 0 plus I sine of 0, which is 1. 1 times 2 is going to be 2, so our first root is 2. If we plug in 1 for k, we're going to have 2 times cosine of 2 pi over 3, which is going to be negative 1/2, times I, plus I times sine of 2 pi over 3, which is going to be the square root of 3 over 2. If we multiply this out, we're going to get negative 1 plus square root of 3 times I. If we plug in 2, we're going to have 2 times 4 pi over 3, which is going to be negative 1/2, plus I sine of 4 pi over 3 is going to be I times negative root 3 over 2. And that's going to be equal to negative 1 minus root 3 times I. And so our 3 roots for z cubed minus 8 equals 0 are going to be 2, and then negative 1 plus or minus root 3 times I. So I'm going to erase this to clear some space. And to solve the second equation, what we're going to do is factor first. So we're going to have z squared minus 8 times z minus 8 equals 0. So our first root is obviously going to be z equals 8, since that makes this part of the factor 0. So we're going to have z equals 8. And then here, we're going to have z squared minus 8 equals 0 to find the roots here. And that's going to be plus or minus the square root of 8, which is going to be plus or minus root 2 times 2. And just using trial and error, we're going to see that 8 and one of these values are going to be the furthest apart from each other. And if we draw a complex plane here, 8, 0 is going to be here. And we're going to have negative 1 square root of 3 over here, and negative 1 minus square root of 3 here. And it turns out that they're actually the same distance from 8, 0. So let's say we use this one, which is going to be negative 1 root 3. And using the Pythagorean theorem, this value right here is going to be the square root of 3, and this distance is going to be, 9. And using the Pythagorean theorem, we're going to have this distance equal to the square root of 81 plus square root of 3 squared, which is the square root of 84. And this is going to be equal to 2 root 21, which is 3. Question number 16, and it reads, a point is chosen at random within the square in the coordinate plane whose vertices are 0, 0, 20, 20, 0, 20, 20, 20, 20, and 0, 20, 20. The probability that the point is within d units of a lattice point is 1/2. What is d to the nearest 10th? So the key realization in this problem is that the 2020 by 2020 square is completely irrelevant to the problem, and that the probability for the big square is going to be exactly the same as the probability for 1 by 1 squared. And this 1 by 1 square, we're going to say the 4 vertices are all lattice points. So basically, we're going to have these quarter circles with the center at the lattice points, and with radius d, which indicates that all of this area right here is going to be within d units of this lattice point. And the same with all these lattice points right here. And the problem says that basically these 4 shaded areas combined are going to have a combined area of 1/2, because the area of this entire square is 1. So we're going to have 1/2 equals 4 times, since these are quarter circles, their areas are going to be 1/4 pi d squared. 4 times 1 over 4 is just 1, so we can just erase that. And if we divide pi on both sides, we're going to have d squared equals 1 over 2 pi. If we take the square root, we're going to have d equals 1 over the square root of 2 pi. So since we're asked for d to the nearest tenth, we can make a few small approximations and say that 2 pi is around 6.28, and the square root of 6.25 is 2.5. So we're going to have d is approximately equal to 1 over 2.5. 1 over 2.5 is exactly 0.4, which is b. So that's our answer. So this is question number 17. It reads the vertices of a quadrilateral lie on the graph y equals ln x, and the x-coordinates of these vertices are consecutive positive integers. The area of the quadrilateral is ln 91 over 90. What is the x-coordinate of the leftmost vertex? So this problem is really long, and I just wrote it all out, and I'll try to explain it step by step. So the first step is to write down the coordinates of each point, and those are n, ln n, n plus 1, ln n plus 1, etc., right? And the next thing I did was use the shoelace theorem to find the area of the quadrilateral, and I ended up with this expression. So this expression will simplify to this expression using a few log properties. The first log property that I used was the exponent property. The exponent property states that if I have b ln a, that's equal to ln a to the b. And this works for any log base. It doesn't have to be ln. It could be log 10, it could be log 2, it could be log 3, whatever, right? And the next thing that I used was the addition property. So that says that if I have ln a plus ln b, that's equal to ln ab. And the last thing that I used was the subtraction property. So if I have ln a minus ln b, that's equal to ln a over ln b, which is how I got this divided by this right here, right? And the next thing that I used to get from here to here was basically just reapply the property of the exponents. So basically I had ln, if you have ln a over 2, let's just call this entire thing a. If I have ln a over 2, this is equal to 1/2 ln a, which is also equal to ln a to the 1/2, which is ln times, or not times, ln of the square root of a. And basically to get the numerator from here to here, I just simplified these exponents and just cancel some terms. So that was how I got from here to here. And at this point, conveniently, every single one of these terms is squared, and I have a square root over them. So basically all these squares cancel, and I'm left with this. And from this, I can just say that this value inside is equal to 91 over 90. And 91 is 13 times 7. So basically what I need is a multiple of 13 and a multiple of 7 on the numerator. And the only answer choice that does that is 12. Because if I plug in 12 plus 1, I'm going to have 13. If I plug in 12 plus 2, I'm going to have 14. So I have 13 times 14, which has a factor of 13 and 7. So the answer has to be 12.